guys, and welcome to the show. We have Ryan back, Ryan Berry, and he's been a guest so often I'm considering renaming the show to Taste of Premier with Ryan Berry. Ryan, how's it going?
It's going great. Yeah, I love being on the show. Thanks for having me back.
Yeah, man. Look, you make the show. I love I love having you on the show because I love the way that you explain things, and you make really complex technical stuff seem easy to people that maybe don't do this every day. And so certainly it's much appreciated, bud.
Yeah, no problem. Yeah, happy to do it. And I know we talked quite a bit about Azure networking in the past two shows you had me on. So I thought we'd kind of take a step forward and start talking about some of the other aspects of running infrastructure in Azure.
Yeah, absolutely. So kind of a virtual machine management thing.
Yeah, exactly. Yeah, some of the ways you can create them, nuances behind that, and how disks, can be associated with virtual machines, how you can back them up and protect them once they're running in Azure. So we'll talk about kind of end-to-end, soup to nuts, how you can manage those those virtualized assets in Azure.
All right, absolutely. Well, I'm not going to hold you back. I'm just going to let you kick it off. I know you've got a slide presentation for us. So let's load that up and get going.
All right, sounds like a plan. All right, Lex, so in talking about virtual machines, under the covers, there's a lot of pieces of Azure that are used to provision a machine. We talked ad nauseum about the networking capabilities and ways that you can set up VPN tunnels from your on-premise environment into Azure, and how you can assign IP addresses to network interfaces of those machines. But now we're kind of going up the stack and actually talking about the VMs themselves. And in doing so, there's 500 plus what we call products or capabilities that exist in Azure today. And one of those core building block components is something called blob storage. And I think we talked about this briefly when earlier a couple years ago when we talked a bit about virtual machines. But functionally speaking, and briefly, blob storage is a kind of a pivotal core building block in Azure that can be used through code, that for software that you write yourselves. Or it can also be used, or it is used rather, for storing the virtual hard disk under the covers for a virtual machine that you deploy into Azure. And then there's a lot of other capabilities that storage has, such as creating something that we call Azure Files, which is an SMB share in the cloud. So there's kind of a number of core capabilities of Azure storage. And virtual machines builds on top of that. And we'll talk about some of the nuances behind that and some of the enhancements that exist with that as well.
Okay.
So, and kind of, there in the middle we have, compute resources, and the virtual machines deployed in Azure have extensions for both Linux and Windows that allows you to do things like password resets of a machine. So if you deploy a machine that's not part of a domain, you need to reset the local user account that you identified when you actually provision the machine. You want to reset that password. That's one of the things that you can do with a VM extensions. There's extensions for deploying anti-malware remotely to machines you deploy in Azure. There's extensions for doing things like backup, which we'll talk a little bit about today. So that's kind of an add-on capability that exists within the Azure environment for a VM that you deploy there.
Awesome.
All right, so let's look at the three different types of ways that you can actually deploy virtual machines. And this looks a little complicated, and arguably there's actually only two listed on here, but I'm going to start with the simplest approach to deploying a virtual machine. And then we'll talk about these other two options. So in here, we talked a lot about virtual networks in some of the last episodes, and public IPs, private IPs, and load balancers, and how you can subnet a virtual network and deploy assets in the subnet, and network security groups, and so forth. This is kind of identifying what you are showing, rather, what you can actually deploy into those subnets. In this case, we're talking about VMs today, so that's what this is highlighting. And in this case, it's showing a group of VMs that are deployed as what we call a scale set, and then another group of VMs that are deployed as an availability set. And thinking about this at the simplest form, you can also just deploy a single VM, with no no high availability, configuration. Just one standalone virtual machine that can live inside of a network in Azure that you can use network security groups to control access to that virtual machine. So that's kind of the simplest approach. And then when you start talking about creating pools of machines, so which would be more typical for some of our customers' workloads where they have a website where they have some number of machines that they want to host that website. So starting with this availability set picture down here on the bottom, what that's showing are two machines that a customer would actually deploy and configure and actually bind those together into kind of a group, if you will. And collectively, those machines would actually be sitting behind a load balancer that is exposed to the internet. And there's an option here, too, that we talked about last week, that you can have a load balancer be internal only. So like if you had a line of business website that you don't want to make publicly accessible, you could actually deploy an instance of this load balancer that's has an internal IP address rather than a public IP address. So what an availability set is, and the way that you actually deploy one of these is let's say that you have a web farm that has 4 servers at max to be able to support the load that you're going to throw at a website. What you would actually do is literally create and configure 4 virtual machines in Azure and tell the Azure Fabric that they're part of a cohesive availability set. And then you can create rules to turn those machines on and off. So based on load, based on requests coming into the website, based on time of day. But the key point here is that you actually have to create
Hang on
sure.
just a second. So that's interesting. So you can actually create rules that look at the availability, say, oh, we're at 80%, time to fire this guy up.
That's correct. Yep.
Wow, that's awesome.
Yeah, and with the availability set, though, in my example with 4 servers, you actually have to deploy all 4 of those up front. So let's say that you can run with one in most cases, and you want to be able to burst to 4, when traffic is high. So you actually have to create 4 individual machines in Azure and give them different host names and make them part of maybe a direct Active Directory domain that you want to maybe centrally manage them. But you actually have to deploy all 4 of them, and the other 3 machines during normal times of operation would actually be in a stopped state. So you wouldn't be paying for them, but you have to have them pre-created up front. So if you wanted to add a 5th machine, you would actually have to configure a 5th machine and make it part of that pool of servers. And the reason why a customer might want to take this approach is that it gives them complete control over what resides in each one of those machines, what the IP addresses are of each one of those machines, what the host name is of each one of those machines. So it gives very granular control over what those individual machines look like. So that's one path that customers can take.
Cool.
Second path they can take is something we call scale sets. That's shown up here at the top. And the way that works is that a customer can give us, using the same example, we have 4 web servers. A customer can actually provide their own image that maybe has IIS pre-configured, maybe their application deployed on that machine, or they can take an image off of the shelf in Azure and use as a base and put some scripting and automation on that base to configure IIS and deploy their application to it. But the point is, a customer only needs to deal with one image. And they can create, like an availability set, they can create rules to expand and contract the number of virtual machines that are deployed. And we just cookie cut, or using that image rather as a template, we cookie cut it to n number of nodes, all the way up to 1,000 instances if the customer needs that many copies of their VM. So the difference between a scale set and an availability set is that the scale set, the nodes are going to be named based on not really randomly, but the customer doesn't have control over how they're named. So let's say the availability set was called Taste of Premier. The first node would be Taste of Premier _1, and the subsequent ones would kind of increase from there. So it behaves a little bit differently than an availability set, but it gives the customer a much smaller administration footprint. instead of having to pre-configure those nodes up front, they can just configure one and kind of set it and forget it.
That's cool.
Yeah. So in either of these three scenarios, like I said, the third one being just a single VM that doesn't sit behind a load balancer, the virtual hard disks, the boot disk, as well as any data disks, sit in Azure storage. And actually, I just realized we made recently a change a couple weeks ago to support 4 terabyte drives instead of 1 terabyte drive. So it's actually a pretty significant increase, and our plan is to continue increasing that to larger and larger sizes as time goes on. So the ability to, arguably in today's world, or today's day and age, 1 terabyte is pretty small. So 4 terabytes is getting better, and customers can have multiple disks per machine that they deploy and kind of stitch them together using storage spaces and on the VM.
Well, who would ever need more than 20 megs?
Right, yeah. Who would ever? Yeah, 640K. That's nobody will need any more than that. Yeah. All right. So before we start diving into some demos, I'm going to highlight that there's a number of different ways that you can create stuff in Azure. And since we're talking about virtual machines, we'll highlight those 3 different ways that you can actually create those. One, the simplest way is through the portal, and we'll walk through that. You can also use a PowerShell. So in Azure, there's a set of PowerShell commandlets for some of what we call the Azure Resource Manager virtual machines. So you'll see they have the word RM. That's what RM actually stands for. So these are VMs in Azure that have been, or actually some capability in Azure with our Fabric that is used to manage your deployments. That was released about 3 or 4 years ago. So any commandlet that you see the word RM in it is referring to some of this newer capability that we have in Azure. So in the portal, when you create a VM, you have the option of saying Classic or Resource Manager, and that's kind of the differences between them. The Resource Manager VMs have some newer capabilities that we won't dive into deeply today, but that's just something to be aware of when you're looking at some of the command line tools. You can also deploy virtual machines using our cross-platform command line environment, and we have a couple different flavors of this. We have a 1.x flavor that uses the word Azure, and then we have a 2.0 framework that was rewritten and overhauled, which is just simply AZ. But the point here is that you can use these tools on Linux environments, OS X, or even on Windows to deploy and manage your environment, and I'll even show how you can use this in the browser. So that's pretty cool stuff. And then finally, a third way that you can actually create assets in Azure is using something we call a Resource Manager template, and this is JSON, which is actually it stands for JavaScript Object Notation, and think of this as a infrastructure as code, a file that describes all of the things like what network are you going to join this VM to, what IP addresses are you going to assign to the NIC, how many drives are you going to have on that. It's showing here in the examples talking about the OS disk and configuring caching options and identifying that this is a Windows VM. So you can actually use this through a REST API, so you can actually have code that passes in these instructions to Azure. You can also take that JSON script, if you will, and deploy it through the Azure portal, and we'll take a look at what that looks like. And you can also use it through PowerShell or other automation tools such as Chef or Puppet to be able to automate the deployment of an environment. Maybe if you have a test subscription and you want to duplicate that environment exactly in a production subscription, that would be a way that you could do that.
Cool.
All right, so let's talk a little bit about the storage. So the storage accounts in Azure have there's some limits to be aware of. Specifically, we have 2 different types of storage that you can actually use to back a virtual machine. Standard storage actually has a limit of 500 IOPS per drive, which again seems low, but you can stripe across many volumes to be able to achieve higher throughput. With premium storage, you can achieve upwards of 5,000 plus IOPS per drive. Just showing what we call a P30, which is a tier of storage that gives you a 1 terabyte disk size, and it gives you some pretty good throughput of 200 megabytes per second. But one thing to note is that when you deploy a virtual machine, you actually pick a size of that, how many cores, how much memory that VM has. And there are some limits that you have to look at in some of our documentation to understand what its limits are. So in this example, if you had a DS3 virtual machine, which I think is 8 cores or 4 cores. I can't recall the number of cores, but it's a smallish virtual machine. You can see that it supports a maximum throughput of 128 megabytes per second. So if you attach one of these drives to this size virtual machine, it would run very fast, but you wouldn't actually be able to obtain the complete throughput of that size disk. So you kind of have to look at those tables and understand what the capabilities are of the disk you're using, and the storage account that you have mapped to your virtual machine, and the virtual machine itself.
Cool.
So yeah, all right. So we've had some pretty significant changes with the way you deploy, how you attach or associate a virtual hard disk with a virtual machine under the covers. And we've introduced this concept called managed disks. And I'm going to switch over to a demo to kind of walk through what the difference is between some of the older ways of actually associating storage with a virtual machine, and the newer way using managed disks, and how that can simplify things for you. All right, Lex, so what I'm in now is the Azure portal, and I'm in the wizard to actually create a new virtual machine. And I populated it with some details on our username and password, and what resource group container that I want to deploy this into. So I was thinking of that resource group as sort of that kind of a management abstraction within a subscription. So there's a way for customers to be able to assign permissions individually for assets deployed into a subscription. So I've created one for our show today, and I'm going to deploy this example VM into that. In here, you also pick whether or not this machine is using a solid-state storage or a standard storage. So when I talked earlier about premium storage versus standard storage and the IOP difference, if I picked the non-premium storage, this would be the 500 IOP per disk limit that this machine would actually inherit, whereas this inherits whatever the tier of premium storage that I pick when I actually create it.
Yeah. So do we actually have racks of SSDs and racks of
magnetic storage. Yep. And I think, I'm not sure, I guess I haven't spoken to the storage team. There might be some direction to move more towards solid state storage in general, and throttle I/O to it, because what we actually do in our data centers is we have clusters that are of resources that are actually dedicated to just storage. So instead of allowing customers to deploy virtual machines to those clusters in our data center, they're actually used. Think of it as a SAN, I guess. It's might be the closest analogy that you could think of it as.
Yeah.
That the host actually communicates with to boot the VM.
Yeah, it's just interesting. It seems to me like it would be, I don't know, easier to just have everything SSD and then just, throttle the IOPS.
Yeah, that might be what they're doing for for some of the newer storage. I do know we still have a pretty significant amount of magnetic storage when I've seen some of the the tours that I've been on at our data center. So just absolutely staggering to see a row of storage clusters with exabytes of storage capacity available. So it's just mind-boggling to kind of see how we do things at scale.
Yeah, pretty cool.
Yeah, it is. All right, so I'm going to go ahead and go to the next step of our wizard here, and doing some validations. This is where, because I picked a solid-state storage, it's going to present to me VM options that have the letter S in them. So like we have a D series VM, but there's also a DS series VM, and the price is actually the same. If I look at the pricing for a DS1 V2 VM or a D1 V2 VM, they're both going to be $104 a month for list rate. The difference being the one with the S in the name is used for attaching to solid state or premium storage. So I'm just going to go ahead and pick this guy. And this is where things get a little bit interesting. So I talked about managed disks briefly, and I thought it'd be easier to show what the difference is, through the creation wizard. So you can see the default is no, and when you pick no, there's a bunch of other options here that are always here. But one of the option, actually, let me go ahead and pick no because it's not showing. One of the default was actually yes, I meant to say. And if I pick no, what it will make me do is pick a storage account that I actually deploy the virtual hard disk for this VM into. And so I'm going to open up something called the Azure Storage Explorer. And this is actually a slightly different storage account. This is actually pointing to, I have two storage accounts that I can use. I'm going to, the other one actually isn't showing up. So I'm just going to show you here from the Azure Storage Explorer. So I have this one called Taste of Premier Disks 344. So it's actually bound to some other VMs that I have running in the subscription. And inside of the storage account, you can see some of the other things that you can do with storage, like I talked about file shares. There's durable queues. There's some NoSQL types things that or storage that you can use for applications you deploy. And in here under the blob section, this is actually where you can actually store arbitrary data, through code, or this is where the VM's hard disks are housed. So under the blob section, there's something it's referring to the word or using the word containers, and the easiest analogy to a container is a folder on a file system. So you can actually create folders within a container, but this is kind of a bucket, if you will, that stuff gets pushed into. So when you create a virtual machine and point it to a storage account, it creates this container called VHDs. And you can see in here there's one with a padlock on it, and the padlock means this particular blob has a lease on it, which means that I'm not going to be able to delete it through tools like this because it's actually backing a VM that's running literally right now. So the key point here is that when I say no to managed disks, I have to create a storage account if one doesn't already exist, or I have to actually point to a storage account that I already have existing in my subscription to actually tell it where I want the VHD to actually get deployed. And the reason why that's significant is that storage accounts have limits to them. So I talked about each hard disk under standard storage having a limit of 500 IOPS. So if I were to deploy 50 hard disks into a single storage account, that would mean I could conceivably need 25,000 IOPS to accommodate all those VMs. If they were if there's a lot of I/O going on all those machines at once. A storage account has a limit of 20,000 IOPS. And this is where customers, they have to know some technical details about how Azure operates. And we had, we have this well documented, but you kind of had to put the pieces together to know, gee, if I picked a storage account, it already has, 40 disks, running in it, which means, 40 times 500, that's, our 20,000 IOPS. If I deploy another disk in it, I actually run the risk of being throttled. And there was no way for you to know that that would happen because we wouldn't block you from overloading a storage account with disks. So that was, good that we gave customers, very granular and discrete control over how they use storage accounts and how they, where they put the virtual hard disks. But we also made it potentially easy for them to shoot themselves in the foot if they oversubscribe it.
So would they get a warning or anything that says that, hey, you're being throttled?
No, they don't.
Just happened.
It would just happen, and obscure things would happen, like if you get it really overloaded, you can actually get in a situation where the kernel isn't able to get a I/O request from the disk in a fast enough manner, and it might think that the disk was just ripped out from underneath it in blue screen. So bad things, random bad things could happen if you oversubscribe that.
Wow.
So
Could, right? Past tense.
Yes, could. Yep. So that's where managed disks come into play. So when I click yes, you notice the storage account option goes away. And what we do under the covers is we actually create storage accounts on the customer's behalf and disperse drives into them. So you can't actually see the storage account. There's some ways that you can actually probe into where they're actually stored and get a URL to be able to copy it from one location to another. So there's some technical ways to be able to see it under the covers, but we have completely abstract that away here. And more importantly, we make sure the customer is never going to end up getting in that situation described earlier where they're going to be throttled to the point or degree that the machine becomes unusable. So, and if I look at, so I'm just going to go ahead and cancel out of this and go to a machine that I've already created. So this particular virtual machine, it's a Windows Server 2012 R2 machine. And if I go to disks on this machine, this particular machine is actually using unmanaged disks. So I can actually, so we're kind of compare and contrast what they look like under the covers. So in here I can actually see this is actually running on Taste of Premier Disks 344 Blob, which if you recall when I had the Storage Explorer open, that is the storage account that I have here. So this in fact is the VHD for this VM. So I can actually see it in this case. And I can also see it from the portal. If I go back in here and actually look at the overview of this machine, there's a resource group I have called Taste of Premier. And in this resource group should be the storage account that I just talked about. And there's a 344 guy right there. So I can also see that through the portal. I can actually browse into it. I can go to containers, and the monitoring, which I didn't let load, would actually show us what the inbound and outbound traffic is, that storage account. So you would get some indicators perhaps that you've overloaded a storage account, because you would actually visibly be able to see that, and if you were monitoring that storage account. But if I click on VHDs, I can actually see the same data that I just showed in that Storage Explorer. So I can actually browse through it here in the portal as well. But point is that the disk is actually sitting out here in a storage account, and if I add 41 more disks to that particular storage account, I run the risk of overloading it.
Yeah.
So if I go to another VM here, and go to disks. This one actually is using managed disks. So I'm going to go ahead and show you here a machine that actually is using managed disks. So go ahead and click on disks. You can see that the actual disk name is cryptically named. I didn't actually pick the name of this particular image, because under the covers is actually given a name based on the machine name. This is actually the boot disk for that machine, and then it's got a bunch of stuff after it. Mm-hmm. And if I drill into this thing and go to overview, in the other machine we actually saw a storage account. This particular instance, we don't actually see a storage account. We actually just get this resource ID. So there is kind of a programmatic way to be able to get to this, but in here I can actually indicate if it's a premium storage account, if it's a standard storage account. This particular machine is actually using a standard storage. It's not using the solid state storage. So you can see I can actually tell what my throughput limits or I/O limits will be on this: 500 I/O or IOPS and 60 megabytes per second transfer speed. And if I go to the storage account, the resource group that this virtual machine is sitting in, and this is in this Taste of Premier scale, and I've got a couple things sitting in here. But you can see there is no storage account. What I do have is a disk object. So managed storage shows up a little bit differently when you actually browse around. If you recall before, when you looked at the other VM, I had to actually drill in. I had to first look at what storage account it was in. Then I had to go into that storage account to actually see it. And here it's actually more of a managed object, and it has some defined properties on its performance. And I don't have to worry about where it resides physically and ever bumping up against any limits.
Yeah. Cool.
All right. So we talked about kind of the differences in the ways that you can actually deploy a virtual machine, and I touched upon the fact that you can deploy multiple virtual machines into an availability set. Another way that you can actually deploy multiple virtual machines is something called a scale set, and that was I happen to have one of these guys created here. And if you recall, when I talked about scale sets, this is where you have a template that you either pull an image off the shelf in Azure and actually use that as a source of your template, or you can provide us with an image that will just a generalized image, one that's been sysprepped, that we actually cookie cut into n number of instances. So in this particular case, I have there's a load balancer that's sitting in front of this pool of machines, and this pool of machines is currently comprised of a pool of 1. You can see that this particular machine has a name, test scale set _2. And if you recall, when I talked about availability sets, you have the ability, you actually pre-create those machines up front. With a scale set, the host name is randomly created, by the fabric. So I don't have any control over how it gets named. What happens is that each machine is kind of given a consecutive number, and then it kind of wraps around when it gets to a really high number, and starts back over at 1. It's in the millions, I think, that it ends up wrapping back around. So you don't have as much granular control over the naming or the IP address assignment, but you do have a way to be able to rapidly add up to 1,000 instances to be able to host your particular application. So if I go to scaling, like what we were talking about earlier, you can actually set up auto scale rules, and I can go ahead and add a rule here, and we'll look at what you can actually associate the rules with. You can see that I can actually look at disk I/O, the network traffic going in or out, the CPU percentage, and I can determine how it's actually averaging or capturing these statistics over time. What period it actually needs to exceed the threshold I define to ultimately increase or decrease. So you can also create corresponding rules to shrink the number of machines in your pool. And then you specify the number of nodes that it actually uses to, or number of instances rather, that it actually adds or removes.
That's cool.
So we can go back here to scaling, and we can move this fancy slider and manually go from one node to additional instances, but that wouldn't be as fun as it would be to use this really new feature that's in the portal. It's called this Cloud Shell. And I'm going to click on that guy.
Any excuse.
Yes, exactly. So this is a bash shell. It takes a second to load up. And while it's loading, I'll show you in the drop-down, something really cool is coming soon, is we'll have a PowerShell environment available as well. And the really cool thing about this is, we rev these tools often. It looks like something just happened. Let me go ahead and go back into it. We rev these tools often. So instead of having to keep all the tools up to date on your machine, and then having to authenticate to Azure, when this shell opens up, it's going to already have me authenticated and allow me to interact with, with my subscription. There we go. So I get a bash shell, and I can actually use the command line tools. If you recall on my other side when I talked about the command line tools that are cross-platform. This is a Linux environment. I can use the AZ command to interact with my subscription, and give it a moment here. It's running a little sluggish. It's running really sluggish. There we go. So this is the command line tools that you can deploy to your machine and use directly, on Linux machine, Mac OS machine, or Windows machine. But you have to authenticate and connect your subscription. The cool thing about this is I don't have to worry about that. I'm already authenticated, so I can actually interact with. I can type in Azure VM list, and this will return some JSON of the all the virtual machines that I've deployed in my subscription. So I can actually shut them down, start them, and so forth. But I can also interact with my VM scale set. So I'm going to type in AZ VM scale set. So this is the command that you use, or the verb you use to interact with it. In my scale set is I'm actually going to tell it I want to increase the number of instances in this scale set. And this is sitting in a resource group called Taste of Premier Scale. And the name of my scale set, which I can see right up here, Taste Scale Set. So my name of the scale set is Taste Scale Set. And I'm going to increase the capacity of the number of instances within this environment. So I'm going to say new capacity, and I'm going to say 10. And let this run for a second. You see it's starting. And if I go to instances really quickly, look at that. So you can see that this is the numbering I told you that you don't have any control over. So it started at 17 because I did this earlier. And you see it goes all the way up to 31. But really within a couple of minutes time, I'm going to have 11 machines that are actually running whatever application that I've deployed on this image that I've actually provided the Azure Fabric.
That's pretty cool.
Yep. So this is kind of the second way to do it. All right. So let's so now we have some virtual machines running, and I'm not going to let this we don't have to wait necessarily for this thing to run. So now you've got some virtual machines running. How do you back them up, and do some of the standard operations that you would do if you were managing these in your own data center? So I'm going to shrink this down here, just let it finish up. So we have some capabilities in Azure called Azure Backup and Azure Site Recovery, and I'm going to go ahead and flip over to some slides and show you what those look like, and then we'll hop back to the portal. All right, Lex, so we talked about different ways to create the virtual machines, the different storage accounts that you can actually map to the virtual hard disk under the covers. But now let's talk about some of the day-to-day operational hygiene of those environments. And one of the ways that you can actually do backups of those machines that are running in Azure is using something called Azure Backup. And this is actually a pretty powerful tool that can support a number of different customer scenarios. The one that we're going to look at is actually doing it from a virtual machine running in Azure, and it can be a Windows or a Linux virtual machine. So we call that cloud-to-cloud backup. So very easy to do file-level backups, and you can actually do file-level restores for machines running in Azure directly to Azure Storage, which we just talked about earlier. Another thing that you can do is actually have a System Center Data Protection Manager server running in Azure that you can actually use to protect assets that you have running in Azure. And you can actually point the System Center DPM server to a vault in Azure to house the backup. So that's another way that you can actually do that. Instead of actually having to worry about spinning up lots of disks to be able to house all the backups, you can just point it to virtually unlimited storage that resides in Azure. But it doesn't stop there. We can actually also support scenarios where customers need, they might have a hybrid environment. Maybe they've got some machines in Azure they want to back up, and they've got some machines on-prem they want to back up. So we support going from data center to cloud, where customers can do file and disk level backup directly into Azure. And we also support System Center Data Protection Manager on-prem that can be used across a number of different types of environments, VMware, Hyper-V, servers, SharePoint, SQL, and so forth. So you can have those assets backing up to a Data Protection Manager server on-prem, and again have that Data Protection Manager server dump the backups into into Azure Backup for long-term retention. So a couple different ways that you can actually wire this up. And we'll look at in a minute a virtual machine in Azure and how you can configure backups. All right, so this slide has a lot of stuff on it, but we have another cool capability called Azure Site Recovery, and this is a product a couple years ago that we acquired from a company called InMaj, and we've revved it pretty significantly over the last couple of years and added a lot of features and capabilities to it. But functionally what it does, let's say that you have an on-premises data center and you have a DR site for that data center. Why pay a colo provider to actually house additional hardware that you have to procure and maintain? You also have to worry about hardware failures on that equipment over time. You have to manage patching of that environment. Why not just take snapshots of those machines that you have running in your production data center, move them to Azure, and in the event of a failure in your on-premises environment, you can actually use Azure as your backup data center and click some buttons and using some rules that you've already defined, spin up those machines using the last backup image or snapshot that they push into Azure. So this works with VMware machines, physical servers that are running on-prem. It also works with Hyper-V Virtual Machine Manager on-prem. But the other thing that you can use this for that's not shown on the slide that I'll walk through here in a minute after I show how backup works is going from Azure to Azure. So in my example, when I was talking about the different ways that you can deploy machines in Azure, at the simplest form, you can just deploy a VM, count or a size of 1. That's not part of an availability set, not part of a scale set, just a simple VM. And let's say it's running some line of business application that might be critical to support your business. So what you can do is deploy that maybe to the East US. And you can, within Azure, replicate that VM as granular as 5-minute intervals to take snapshots of that VM running in the East and shuttle it over to the West. So should something, knocking on lots of wood here, catastrophic ever happen in the East data center in Azure, you can use this same process to spin up your machine in the West US. And we'll talk about how that works, and I can show you in the portal because there's some pretty cool things that you can do with it.
Cool.
All right. So I have the ability to actually associate this this virtual machine with what we call a recovery services vault. So this is actually, think of this as the storage environment that all the backups are deposited into. Well, I happen to have have a couple storage vaults already created. So I'm just going to go ahead and pick one of these, and there's a policy that I have defined within that particular recovery vault, and it's just a default policy that basically does a daily backup at 12:30 a.m. And retains each backup for 30 days. So that's the default policy that's associated with this particular recovery services vault. So if I click Enable Backup, it's actually quite literally that easy to associate the Azure Backup Service with a machine in Azure. And I'm going to go to one that I already have backups associated with, and if I go to Backup, so this one actually has some backups that have occurred. You see I have 30 restore points over the last 30 days. 7 over the last 7 days. And I can actually see all of the backups that have occurred. And I can actually, I can from the portal actually restore this VM from a backup, or I can actually do file level recovery. So let's say that I accidentally deleted a file and I actually want to restore that. So one way that I can do that is by downloading a script locally to this virtual machine. And what actually happens is the storage in that recovery vault is mounted as a drive on that virtual machine. And I can just browse and find the file that I accidentally deleted and copy it back. So that's what this is actually walking me through. But I can also do that. I'm going to connect to that virtual machine directly and show you, what you can see with the backup client that's running on that machine. So, letting it think here for a second. And I'm going to say connect. Right. Connecting. Let me move this over to my other monitor. All right, so I have the Azure Backup agent already installed on this machine. And this is the machine I was just looking at from the portal that I can just go to recover data. And I'm going to tell it I want to restore to this server. I want to restore individual files and folders. And it's going to go through and say what volume that was backed up do you want to actually restore from. And I'll just pick yesterday. And when I click mount, it will actually mount that particular backup as a volume that I can then copy files to and from for restoration purposes. So that'll take a couple minutes. Yeah. So really easy and straightforward. Backup as a service or disaster recovery as a service. All right. So the final cool thing that we'll show. When I go to Recovery Services Vaults, this is actually where that repository where the backups are actually housed. So I can actually see, this is that ACS test that I just configured that other machine to go to. I also have this other vault called ASR West. So this is actually where I have Azure Site Recovery actually configured for a machine that I have running in my subscription. So if I go to Site Recovery and say replicated items, it's actually telling me it's in a critical state because I haven't had this machine on in a while, so it's actually behind on replicating it. But this particular virtual machine is replicating. When this loads, you'll actually see some detail. This is running in the east, and it's actually
look at that.
This really cool animation.
Are those actual data centers?
Yep, those are actual. Those are Azure regions. So I actually selected the west region as a location that I want to actually replicate this thing to, and you can see active region right now is active in the east, and my target is west. So cool thing about site recovery is it's two-way. So if I were to fail to the west and then maybe service is restored in the east and I want to go back, I can actually move the direction of that flow of data from the west back to the east. And it would replicate changes that would have occurred while I was running in the west back to east, and I could I could start running it again back on the east side.
That's cool. So you've got one critical event there.
Yeah. This is actually, like I said, this machine was just started up earlier today, and it's behind. Yep. And it looks like there's also an agent that I have to actually update on this machine. Yeah. So there's a couple of things that it's not really healthy, but
so as soon as the backup gets done, that'll clear.
Yes. Yeah. And it looks like I do have to update that agent on here. So, so some other things that I can do with this machine. So let's say that you want to deploy, maybe you got a line of business application and you want to deploy some OS updates. And maybe some .NET updates. Maybe the line of business application is written in .NET. Sometimes there's some sensitivity to some code that you've written that might break if you deploy an update to .NET. There might be some breaking changes, in other words. So now that we have snapshots of this machine flowing over to the west, what I can actually do is something called a test failover, where I can actually spin up a new VM into a isolated network. So I could actually create another network in the west that is different from my production network, and tell it I want to restore, from the last, recovery time objective of this VM, and actually create basically a complete image of my production environment in an isolated network that I can use for testing. So
that's pretty cool.
Yeah, I have customers who have actually used this for moving, for upgrading their version of SharePoint or updating their version of SQL, something that's fairly, critical to their environment. They can actually exercise this over and over again, kind of get their plan in place and validate that it actually works, and then do it for real. So this is a really cool way to be able to validate functionality, and oftentimes it's difficult to actually do a DR drill. Customers I've spoken to that have a colo, it might be a significant amount of effort to change all the network plumbing and so forth to fail over the colo. And this is a way that customers can actually fail over to their production network or maybe to a test network to see how a DR would actually respond in the event of an actual emergency. So you can kind of use it in a couple different ways. So if we actually go to the recovery plan, so we have data replicating, but how do we actually, what rules do we use to provision those machines in the west should an event occur? So if you think about a situation where you have maybe a SharePoint farm, so you've got directory controllers, you've got a SQL box, and then you also have a SharePoint farm, and maybe some other myriad of other ancillary resources that you need. In the boot order matters. You want the directory controller come up first, the SQL box come up next. In here, I actually define the how things fail over. So it's a D1 VM in the east, and I actually tell it what size I want it to be in the west. And this is really important if you are failing over from an on-premise environment into Azure, on-premises environment into Azure, because there might not be a direct mapping of core count and memory sizes between what you have on-premises and Azure. So in this case, it's actually detecting, hey, I've got a D1, D2 VM. There happens to be one in the west, so it's directly mapping it here. But I can actually override that and change a different size VM when it fails over. In here, I can also see, this is the network it's running on in the source. This is the network that it would be running on in the target. So I can, define those parameters here. And what I was actually looking for here, I have to find as part of the recovery plan is the boot order. All right, so I clicked on that instead of hitting customize. So this is actually how the failover works. So in here, I can actually see, this is kind of a simple example because I only have one VM, but I can create groupings of machines. So I can actually create a group of my directory controllers, have it actually boot up first, and then I can actually kind of create the boot order in which it actually starts machines up. So you can see that I can actually add an action that occurs before it starts up these machines. So maybe in the case of my directory controller, I can actually, I want those to be up and running before I actually start up my SQL boxes, and my SQL boxes to be up before I start up my SharePoint machine. So you can control the mapping of size as well as the startup order.
Yeah, that's really cool.
Yeah, so that was really all I had to show everyone today. We kind of talked about virtual machine management, and then we talked about the basics of backup, how we can actually insulate those machines from failure. There is one really slick thing that I want to show, this really new capability in Azure.
Okay.
And this aligns with the fact this is called a Taste of Premiere show. So, assuming we have a lot of folks who have Premiere support, watching. So if you have, services in Azure and, if stuff happens, occasionally there might be network interruptions or hiccups that might disrupt services that you have deployed. And you can do a couple things here. You can actually see a history of issues that might have occurred that actually impacted, services that your subscription was using. And that's the key point here is that we have a publicly accessible service health dashboard. And the challenge with that is it's showing global service availability, and it doesn't really directly correlate to your stuff. This is showing the correlation of events or bad things that might be happening in Azure, or even maybe isolated things. It might only be affecting 10 or 12 customers. It might not even show up on a service health dashboard. You have the ability to see some notifications of that through the service health history. So showing, we had an issue a couple days ago with Visual Studio Team Systems with Active Directory. I'm actually a user of Visual Studio Team Systems, and it's actually telling me some details of that particular event. I can actually see the root cause, what the mitigation was. So I can actually see some information about things that are impacting my subscription.
Yep.
I can also see any planned maintenance events. So this is something a lot of customers have asked for. When we're doing, host maintenance that might impact their virtual machines, as an example, they want to be notified. And this actually is a good way for them to actually set up alerts. When we do that, perform those sorts of events and kind of see details of that. We haven't actually done anything disruptive in quite a while in Azure, so there's nothing that's showing up here. And I can also drill in and see all of my services. And the cool thing about this is I can actually filter this. Maybe I've got some very specific services that are really critical. Maybe Azure Active Directory we can use as an example. So there aren't any active issues on here, but I can actually pin this this map to my dashboard. And when you do that, what you actually get is this pretty cool service health map. This actually, when I click on it, everything's green, thankfully. It's going to take me to a filter list showing any issues with that particular critical service. So you see I've got a bunch of regions selected, and I've got a bunch of services selected. So it's saying that all is well in Azure world right now with the locations that I have picked.
That's awesome.
Yep.
Yeah, I know a lot of customers that would just love that.
Yep. And occasionally we might detect something behind the scenes that might be important for a customer to be aware of. So maybe it's not really an outage, but maybe the customer is running on a storage environment that's running slow. It's been reported as running slow. And we might have some specific instructions that we might want to give that customer. So we can actually push those types of instructions to this portal as well. So it's a good one-stop shop to get outage information, outage history, maintenance information, as well as important notifications from engineering or from support the customer might need to apply to their subscription.
Cool.
Yeah. So any other questions, Lex?
No, I think this is awesome. It's neat to see the different storage options and backup options that we have. I love the health advisory stuff. I think that's awesome. Really the bottom line is customers want to know a couple of things. Number one, what's Microsoft doing? Is it doing anything that's going to affect the availability of the services that I need? So that's awesome.
Yep.
And number two, hey, what's going on behind the scenes? And so, no, this was great, man. I really appreciate you doing this for us.
Yeah, no problem. Yep. And to your point on the so what I showed in Azure Health is a kind of a list that you can actually view in the portal. But you can also set up SMS or email alerts around those particular Let's say that you've got a bunch of services in Azure, but you really only want to be notified if your production stuff is impacted. You can actually set up alerts around that very specific service, and you can wire it up to ServiceNow or maybe other notification tools or management tools you use on premises, and you can also have it do push SMS alerts or email based alerts. So really cool stuff. We've made a lot of investments to make that experience better for customers.
But here's the real question,
mm-hmm.
right? And this is what I think all our customers are really kind of wanting to know about Azure, and that is, can I use a Zune to access it?
Yeah, absolutely. We have a new application that was just launched to do to manage your Azure subscription from a mobile device. So that's I'm not sure if it would run on a Zune. That would be interesting to check.
Yeah. But if you do still have a Zune, you could probably subscribe to Taste of Premier on it.
Absolutely. That you can do.
Yeah. By the way, we were playing around with these before we started the show today, and I thought this one was completely dead, but if you look at it, it's got a little charging icon now. So you were right, Ryan. It was that the battery was just kind of too dead to respond. So I'm just going to let it sit and charge for a few more hours and see if it actually powers up.
In another 10 years, you can sell that sucker to the Smithsonian. So.
That's right. Yeah. I'm thinking about donating this one to Marvel because they might need a second one for the next version, for the next iteration of Guardians of the Galaxy. Yeah.
So Groot can rock out.
Even comes with the official Zune case.
I want to see you walking around next week in Vegas at our technical conference, sporting that on your belt.
Yeah, that would be awesome. You know what? I think the case shrunk because I don't think I can get it back in the case. Hang on. Now it's a challenge. Is this the right case for this? Oh, this might not be the right case. I bet this is the case for the 120 gig. Oh, yeah, that's what's going on.
The 120 gig, you got to have more physical space in the case to store all those physical bits.
No. The 120 gig is actually smaller than the original Zune.
Oh, okay.
Yeah, here, check it out. I'm going to do this one more, just for the benefit of folks at home. But yeah, see the size difference?
Oh, no kidding. Okay, so that was a newer generation. Okay.
This is the first original. This is the second gen.
Okay.
And I do have a third gen around somewhere, the Zune HD, but I have no idea where that is.
All right. Well,
all right.
good.
Well, listen, thanks again, man. And I can't wait to have you on again. I think we're going to probably do maybe some express route stuff next time I have you on. And just maybe go through step by step how to set that up. So something to look forward to.
All right. No, sounds good. Thanks for having me on.
Anytime, guys. And that's your Taste of Premier.